Today we're looking at piecewise functions. I have a few students that are going to be gone, so as they were looking at these, they wanted the video so I could post that for them. What is a piecewise function? Absolute value is an example of one. It is a function where the rules are different for different parts of its domain. For example, absolute value of x equals x when it's greater than 0, but if x is less than 0, that absolute value might come out to be negative if we are looking at that. So when we are looking at this, a piecewise function is just a step function. By putting a step, that means it's closed at one end and open at the other. Sometimes you might have a function where there has something like this, where it is open on one end and closed on another end. And that's another type of function, and you're going to see that in this video. But the key thing is that it's missing either the right endpoint or the left endpoint as we look at that. As you watch this video, they're going to show you some information about the different ways we can think of these functions.
The grocery store is full of delicious treats. This imported cheese costs $1 per ounce. If you wanted 7.9 ounces, you expect to pay $7.90. But suppose it's your lucky day. The supermarket is charging for only every full ounce. You pay $7. 9/10 of an ounce is free. Here the price steps down to the next lower dollar amount. But what if the clerk tried to charge you for more than you received, say $8 for the same 7.9 ounces of cheese? In this case, the clerk steps the price up to the next whole dollar amount. Not to your advantage. Step functions, named for their graphic appearance, can associate a number with the next integer up or down. This graph represents stepping down, paying $7 for the 7.9 ounces of cheese. Here, x represents the weight of cheese, and y represents the amount you are charged. Floated dots represent part of the function, but open ones do not. This step function is the floor function. F of x equals the floor of x. As each value of x increases between integers, the value of y doesn't change. But when x reaches the next greater integer, the value of y jumps up 1 unit or step. Time to pay another dollar. If you input the cheese's weight is not an integer, the floor function associates it with the next integer below. So you pay only for 7 ounces when buying 7.9 ounces. Another step function is the ceiling function. F of x equals the ceiling of x. Here's the graph. The ceiling function works opposite to the way the floor function does, stepping up rather than down. The ceiling function has this major difference. As soon as x has a value any greater than an integer, the value of y jumps to the next greater integer. Like when the store tried to charge you $8 for only 7.9 ounces of cheese. You might want to avoid stores that charge this way, since you usually pay too much. But these step functions can be useful if you need to know the next higher or lower integer value. Other step functions allow for the rounding of numbers down or up. Also, step functions can round to the nearest step of any place value, not only integers.
So as we look at this, at the bottom of that page right below the video, what I want you to write down is how does a ceiling function and how does a floor function look? So you should write on your notes, floor function. Now you notice it kind of looked a lot like an absolute value, but it wasn't quite. And if you look at the floor function, remember that's when f of x is going to equal, and they kind of have this bottom bracket with x. And what it's showing you is that it includes the lower number, but not the top number. It includes the lower, but not the top. And this is what our floor would look like. Whereas if we are looking at a ceiling function you should have in your notes is going to be just the opposite. In a ceiling function, f of x is equal, and what you notice that they kind of have this top part of the bracket. And what that's trying to tell us is that the bottom is not equal, and then it goes to a close. So if we are looking at this one, our ceiling function, I'll put this in green. So our ceiling function we can see in green versus our floor function that's in black. here you're going to see some different examples. This one, if we look at enclosed on the top, would be our floor function with the weight in ounces. And if you go into a store and you buy 1.5 ounces for your stamp to mail your letter, you are going to have to pay for the 2-ounce price no matter what. Here's another one where it says when x is less than 0, it gives us the equation y equals x plus 2. Y equals x plus 2 is right here, this function, only when it's less than 0, so it's an open circle. And when x is greater or equal to 0, it's a closed circle, and we would graph our second function. You also see this one is also a piecewise function, looking at the x squared and then y equals the linear function. So you can see a piecewise function just means you want to break our graph into pieces. As you look at this table, this is a nice way that you might see a piecewise function being graphed. It says the amount of income tax for a single taxpayer owes depends upon his or her income. This table shows the brackets for different levels of income for every year. Now, if you just started working, down here, make sure you label your income tax bracket. And remember, tax bracket, what we're talking about, is that's a percent. So we're talking about percents. So if this is 100,000, we have 50, 25, 75,000, and they're going up at $25,000 increments. Our taxes, our first tax bracket, if you weren't anywhere from 0 to $8,500, so closed at both ends. This is a pretty small one if we are thinking about this. So this is closed at both ends because if you earn less than $8,500, you only pay 10%. What if you earn $8,600 or greater than $8,500? You are now paying 15%. 15% is going to be right in the middle here, is where our 15% is. And that would be an open circle at the 8,500 up to 34,000, where it is going to be closed. If we go to 25%, again, 25% is from 3,400, so we're going up from that amount, 3,400, where it is open, up to 83,000. 83,000 means that we want to take a look at that being closed on the top. Anyone less paying in this range has to pay 25%. 83,600 is going to start at 28%. So we are now at our 28%, and that's going all the way up to 174. So where's our 174? Well, here's 175. Again, it's going to be open. So it's going to look like quite a bit larger. People are paying 28%. How many people pay 33%? Well, that goes from 174. So if we are looking at 174, again, that's going to be our open circle, up to 379. So getting close to that 400,000 if we are looking at that. So that's going to be our closed circle. Next, we are looking at from 379,000 and greater. Those people are paying 35%. So we would now have an open circle, and that's for everyone else. As you take a look at this one, it says make a graph to show a relationship between the number of students X that go to a football game by bus and the number of buses Y that you need each bus to hold. If we are taking a look at this function, what we want to take a look at is this is our Y function is going to be the buses. So if we are looking at that, we are talking about our buses. Let's see, I need to make sure it's a little trickier to write on this sideways. This is our buses. And down here, we are looking at the students. We want to think about what is our scale going to be. So what does the point 0, 1 tell us? If we think about that point 0, 1, remember we're talking about students on a bus, and it says each one can hold 50. So I might put my number of students at 50, I might have 100, I might have 150, I might have 200, and 250. If we think about having 250 students, how many buses? Well, remember, each bus holds 50 students. So going up the number of buses I might have, this might be where I have 1, 2, 3, 4, 5. For the first bus, I have to have, if we think about this, I have to have greater than 0, I can't have 0, up to 50. At 50, I'm still taking one bus. So What does the 0.01 tell us? The 0.01 tells us that 50 students are going to be on one bus. The other thing it tells us is that it's going to be closed at 50 and open at 0. Why? Well, 0 students, we're not taking a bus, but for 1 up to 50, we're going to have one bus. It says, what is the X value where will only be one bus for the game? So if we are looking at this, what point is this on the graph? So what is the last X value? The last X value is 51. At 51, we are going to have one bus. Will it be closed or open? This should be closed. And if we are looking at this, the last X value that goes on that bus is our 50 students. What will the point 52 tell us? Well, at 52, when we are looking at that, that's telling us that it's going to be open. What it's telling us is that we need 2 buses with a max of 50 people on each. So this means this bus would actually have 51 to 100 students on it. So if we are looking at this, to 100. On bus 3, we can't have 100, but we can have up to 150. On bus 4, up to 200. And on bus 5, we would have, if we have more than 250. So this is what our step function is looking at. It says continue until 236 fit. How many buses are we going to need? Well, for 236, we would actually need 5 buses. Tomorrow in class, we're going to be working on a worksheet. We're going to be filling these in. The key thing is to just look at when it's going to be open and closed as you're looking at your graphs. So take a look back at the tax bracket, and we're going to be practicing these in class. Hope this went well.